Good morning, children. So, yesterday we had the discussion of around two mirrors. Let us continue with the same numerical which I had left in the last moment. So, that was third numerical on the candle flame image. Okay, well. So, question given was you are placing. So, actually, there was a wall. So, let me draw the wall. So there was a wall. So imagine this is the wall is the which you are kept like this in front of the concave mirror. So this is wall is the and you had kept the object that is candle flame was given I think at 3 meters. Let me refer the question. So the candle flame height was 3 centimeter, whereas the distance of that from the wall was how much? 3 meters given. Okay, well, and again that it forms 9 centimeter high image of the flame on the same wall. Okay, well, so suppose if I take its axis. So this is the pole of the mirror is the now from this side they have given that the object is at the 3 meter height, but image is forming the height is 3 centimeter. Image is forming how much children? 9 centimeter. Means it is magnified one thing. But the question may be coming to your mind that why not? Why not the wall is behind the mirror? Okay. Now your wall is like a screen children. It is just like what? It is just like a screen. And what I have told, you can catch the image of a screen, image of the screen only if it is forming a real image. Only real images can be taken on the observed on the screen, caught on the screen, not the virtual. If we have one more magnified image, in case of concave mirror, when you place between the pole of the mirror and the principal focus, but that is going to be what? Virtual. Behind the mirror, virtual, which we cannot get it on the screen. Hence, we have to take another portion, which is that portion between principal focus and what? Center of curvature. So let's assume that this is the principal focus is there. This is center of curvature is there. And certainly that flame what you are seeing, flame of the candle, only I am taking flame. So flame of the candle which you are seeing of 3 centimeter height. What is the height of this? This is 3 centimeter. This itself is our object. Okay. Now this flame image is forming what? There again on the screen itself, that is on the wall itself. But when it is a real image, it should be what? Inverted, and we are getting its image. Okay. So lateral inverted also should be there as well as inverted also. Okay, linear inverted also. So we are getting is of how much height? The image is formed here, which is of height 9 centimeter there. Hope this much is clear. And your question is to find. Okay, what you have to find? Your question is to find the how far from the wall must the concave be? This complete distance you have to find. What this complete distance becomes? The distance of the image from the pole of the mirror. What will you call? Image distance system. Okay. So you are measuring actually distance between the wall and the concave mirror. But that becomes what? That becomes the image distance itself. Okay. You have to find this image distance as well as you have to find even the focal length of the mirror also they are asked. Okay. So we have to find the image distance as well as we have to find what? Focal length of the mirror also. So these both to be formed. So let us go with the question. So given, okay, what is given now? Given is I is given as how much? I is given as 9 centimeter. Okay, so that is minus 9 centimeter because downward direction you take it as what? Below the principal axis, negative. Yesterday, some of you had the doubt regarding taking negative, positive. Some questions we are asking. So be clear. The data is given, or if you assume something like x and all, we are going to assume. Okay. If I take data given, so that supposed to be what with sign conventions. Whereas whatever you are going to determine, like focal length, I will determine. I know that concave mirror focal length should be what negative. But I won't apply that answer, okay? So I will get my answer as what? Negative. If negative answer is not coming, means you have gone wrong. Hope it's clear. So I is what? Minus, okay, 9 centimeter. O is what? Above the principal axis, positive. So plus 3 centimeter. Hope it is clear. Okay. And what else I get? The object from the wall is at a distance of how much? 3 meter. This is none of our data actually to mention. And let me assume this distance I will take it as x. What I will do? I will take this distance as x. What is x then? X is nothing but object distance. So I will assume as if u as what? Minus x. Okay, centimeters. Oh, sorry, meters. Because distances are in meter. So let us take u as minus x meter. If I take u as minus x meter, what is this total distance is actually x plus 3. Then I can take v as I can take v as minus of x plus 3. This is our data. So understand, this is our data, but I have taken what? Image distance is what? Negative. You have measured. As if given I have taken. Okay, I assume something x. Why I am taking like this? Because both are unknown, we cannot find the average. Okay, well, let us continue. Now, we have to find is what? We have to find these two things. One is we also have to determine finally. First, you find x for that, as well as I have to find the f. These both data we have to work with. So, first, I can directly get the relation between these two, and even I can solve for x taking magnification, children. So, what is magnification you are having? We are having it as minus v by u. Minus v by u. So what is magnification if you calculate? What is magnification you are going to get? See, our formula is actually, I will show you here. Understood it is 3 times, and whenever the real image is there, what I have told you, you have to take it as negative magnification. It comes, not like you should take. Why we have to fix those understanding is because they are going to always negative. Okay, see I can calculate here. M is what actually? By definition, I by O children. I is what? Minus 9. O is plus 3. So how much you are going to get them M as? M became how much? Minus 3. So substitute here. Minus 3 is what? See, this time you can say when you are solving your objective question. Because we know that 3 has become 9 is what? 3 times. See, this much time you can say. And we know that magnification should be what? Negative whenever the real image is formed. Okay, so obviously we are going to get as what? Minus 3. Okay, so minus 3 equal to minus. What is we are having? Minus of x plus 3 divided by, we are having minus x. Okay, now your minus got cancelled, minus got cancelled. So what we are having there? 3x equal to, we are having x plus 3, or 2x became equal to what? 3, or x is how much? 1.52 meter. Okay, so if x is 1.5 meter, then what is going to be your v then? Because question is to find v. V becomes how much? V becomes minus of x plus 3. So x is only a distance. Don't apply in minus 3. Okay. So when you are writing u, you are writing minus 1.5. Okay. So that becomes minus 1.5 plus 3. You got as minus 4.5 meter. Okay. So we got minus 4.5 meter. What is u then? You are having it as minus 1 point because u is x system. X we have got as 1.5. So minus 1.5. Now these both datas are available. You have to find is f. See, choice is reverse now. We are having two formulas. So just I can use m, u, f relation also. Or I can use 1 by f equal to 1 by u plus 1 by v also. So left to you. So 1 by f equal to 1 by u plus 1 by. Okay. I said what you are finding you should not apply sign convention, but these are like no. See, initially if they are not known also, once in between when you determine, already like I got that. When you are substituting in the next step, please take with sign convention. Okay. So I have take minus itself. Okay. So you became what? Minus 1.5 and V is also what? Minus we are having 4.5. So that becomes the you can have 4.5 itself as the LCM. This became minus 3 minus 1. So we are going to get as the F becomes how much children? Minus 4.5 divided by 4 we got. I think we'll get to 1.1 something. Okay. So 1 to 5 may get. 1s are 10 to 5. Okay. So focal length is 1.125 meter we got, whereas we got the image distance, which is indirectly. See, if your question is find the distance between the wall and the mirror is there, you should not answer as minus 4.5 because when I speak it like image distance is negative, okay? But the question is only to find geometrical distance. Then options will be given as well only 4.5 because question is find the distance between wall and the mirror. So distance is what? Simply 4.5 meter. So your answer is what? So distance, if I call this as a distance, we got as 4.5 meter between wall and the mirror. So obviously your answers will be given as 4.5 meter and of course this should be what? This should be negative. And one more thing. Again yesterday somewhere having doubt because option was given as positive I think. See when you find according to your sign conventions, but if you are solving your object questions, literally you should have the habit of having a glance at the what? Glance at the options. If option, suppose I have to get 120 centimeter, minus 20 centimeter. But if I am having only 120 centimeter as one of the answer, then go with that because they are not considered the what? That sign convention the final answer. Okay. But if you are having 20 centimeter as well as minus 20 centimeter, your answer should be what? Minus 20 itself because you have got minus 20. Clear? Because sometimes options will be given only magnitudes, their absolute values. Okay. So modulus values. In that case, don't worry about minus sign. But your job is always to carry on with the sign conventions. Okay. You have to finish because otherwise, in any addition subtraction, your minus sign will affect. So apply the sign convention. But finally, no doubt worrying if you are not having an option with minus. So because they are like in this case, they are asking only distance. Even they ask focal length also sometimes they will give only positive value because they are not considering that finally sign convention the answer. Hope it is clear. Okay. Well, let us move on to the next question. The next question is a dentist concave mirror has a radius of curvature 30 centimeter. What is given data is the radius of curvature is 30 centimeter means focal length becomes what? 15 centimeter, and dentist will use what? If they won't use, also you have to understand, it's using concave mirror, okay? That should be what? Negative, minus 15 centimeter. Fine. How far must it be placed from a small cavity in order in the teeth? Okay, obviously. Cavity in order to give a virtual image magnified 5 times. What is the question? How far the cavity should be there, his teeth should be there from the mirror so that he can get a magnified image how many times? 5 times. And what I had told, a dentist will keep that teeth between the pole of the mirror and the principal focus. He won't measure, means he'll bring very close so that he can see the image of that behind the mirror, means inside the mirror. Inside the mirror you are feeling, not on the screen you are catching. Meaning is what? It has become virtual already. And virtual magnification we take it as what? Positive. Okay, we have virtual image. Virtual magnification we take it as positive. Okay. Now this is given. So yesterday in the afternoon video, if anybody has not observed, please go through it. So one more video was done yesterday, one more class was taken of around 20 minutes where I covered some more formulas, 2 more formulas, and there was a relation between these directly. What was the relation? Magnification can also be given as f divided by f minus c. I think while deriving this, by taking minus 1 by m this side, I had kept as it is. So slight one sign problem was there, but this formula comes finally I have written this. Okay. Just substitute the things. So focal length is given, minus we have taken. Fill the values, simple, very simple question. 5. This is minus 15 divided by minus 15. U we are finding, what we are determining, for that we should not apply the word sign convention. So keep as it is, minus. If given I will apply, otherwise I will not apply. Okay. So what this becomes then? So this 3 is up. So carry on, minus 15 minus u equal to what? Minus 3 is the, or if I take it this side, it become what? Minus u equal to minus 3 plus 15, which is plus 12, or u became how much? U became minus 12 centimeter. Okay, hope everyone is clear. Okay. So we got minus 12 centimeter. Well, the answer is given as 12 centimeter. Understood? Okay, it should be what? Minus 12 centimeter, because the object is always in front of the mirror. Okay. Well. Now, next question we are having is, it is a similar question, so I will skip it, but we go for different. Okay, we go for a convex children, convex mirror example. So I am taking directly the 7th question. The remaining you can, they are on the same formula and on the concave mirror itself. When an object is placed at a distance of 60 centimeter from a convex spherical mirror, so what you are having? You are having is a convex spherical mirror. Okay, and you are keeping an object at 60 centimeter. Your reflecting surface is this side, you have to keep this side itself 60 centimeter from the convex spherical mirror. Okay, and the magnification. So suppose if I keep here at a distance of 60 centimeter. AB is what? At a distance of 60 centimeter. Obviously, we know that in case of convex mirror, irrespective of you keep object anywhere, where the image is going to be between F and pole of the mirror, is within the principal focus itself. What they get is, it is forming an image whose height is half of the height of the object. Okay, and it's always virtual. Its magnification is what? Plus half. And where should the object be placed to get a magnification of 1 by 3? Okay. So already it is forming. In this situation it is forming what? So let us write the first situation. Now there are two situations. In the first situation what we are having? U equal to we are having. Let me call it as U1. Okay. U1 equal to what we are having? Minus 60 centimeter. U is always negative for a real object. Remember, okay, very good. Whereas we have got the magnification given is how much? Magnification given in the first case, okay, we are having is the plus half because virtual image. Second round, before finishing that, I need any of focal length or some other data, be something like that. So let me go for the what? Let me go for first finding focal length. So we can solve the things. So using this first find the focal length, just know how to give a formula. F divided by. Now no F1, F2. Mirror is same. Mirror is same. No F1, F2 children. So F divided by F minus U1. This is half plus half virtual. F itself we are finding, no question of applying sign convention. Hope at least after solving these around 4 numericals, you are comfortable with sign convention. Whatever I am finding, I am not applying sign convention, but understood. Your mindset should be there. Focal length of a convex mirror is what? Always positive, because you measure, this is the direction of incident ray from the object, okay? So you are measuring in the direction of incident ray, focal length, okay? That should be positive. So focal length of concave mirror is negative, convex mirror is positive. That is already fixed. So I have to expect my answer as what? Positive. Otherwise wrong, okay? Well, so F minus, but U1 is given. Minus of minus becomes what? 60. Okay, so calculate that. This becomes F plus 60 will be equal to 2F, or F itself became how much children? 60 centimeter. See, we got positive. Okay, we got it as what? Positive. Now apply for the second situation. What is one more question is there? Now you have to find where should you keep the object so that its magnification, you always, it is going to be what? Less than 1 and virtual, positive itself. Its magnification, M2 should become what? 1/3. 1/3. So again use the same formula. So if I use the same formula, so magnification M2 will be equal to what? M2 will be equal to, we are having F divided by F minus U2. I have to find this U2 itself. So the things are calculated correctly everywhere. Let's check them. So M2 is expected is how much? Already again condition is okay. 1/3 I should get. Like that I have to keep the object. So 1/3 will be equal to. So F we have got already. 60 is the, so positive. In the case of convex mirror with sign convention only positive. Okay. 60 minus U2. Okay. So how much it becomes? So we are having it as 60 minus U2 will be equal to 180, or minus U2 equal to 180 minus 60, that is 120, or U2 is what? Minus 120 centimeter. Okay. So where we have to keep that? Minus 120 centimeter. So you can parallel, even you can have a conclusion. See, when I had kept at 60 centimeter, what I had got? I had got half of that. Okay. Image was reduced to half. Now it is coming what? For 120 it is coming to 1/3. Means as I move away, what happens? The image height goes on decreasing. Okay. If I move the object away from, in case of convex mirror. In case of concave, we are having different situations. Okay, because if I am at infinity, it is very diminished. So as I bring it near what happens, it starts becoming diminished itself will be there until what? Until C position. Okay, at C position will be of same size. If I go inside, its height again starts increasing back. Okay, but in this case, convex mirror, as you move what happens, its height goes on shrinking. If you go to infinity, it becomes point size because that time form the image at what? Yeah, means even this moves away. Okay, as you move away this one, this also moves away, whereas height also what? Goes on decreasing. It will be like this. Okay, at infinity it will come to what? Principal focus, but height also becomes what? It goes on decreasing and shrinks to what? Point size. Oh, all of you got it. Now before going for the next numerical I will leave it to you to solve. It's on the area, but that concept I will explain. Okay, instead of explaining the numerical, let us go for the concept. Okay. In case of concave mirror, so let us discuss some more magnifications. Some more magnification, children. See, already you learned one magnification. That is, when you are keeping object, a linear extended object. So suppose if you are keeping here, cell called as AB, we had got the image what? Which was diminished. This height was less than the what? The object height A dash B dash. It was between the F and C. Okay, we are not discussing regarding image formation now. Let us go for the magnification. So what we had called this magnification as, I had told that this is known as a linear magnification. Linear magnification, children. So which is given by m equal to what? The height of the image by height of the object, or you can use the notations as what? I divided by V. Okay, which we got further as what? V derived as minus V by Q was. Hope this is clear. Now, for this, there are two more terms. If you come across somewhere in your objective questions while solving, so let me make it clear. These are also known as linear magnification, is also known as lateral magnification, lateral, okay, which you have come across. Lateral magnification or even transverse, because perpendicular to the what? Your principal axis. So transverse, get used to these new terms, transverse magnification. Okay. What we got? Linear magnification. We are having this. The same linear magnification, the height of that what you are called, is also known as what? Lateral or the what? Transverse magnification. Now, this is one magnification. Suppose if you are having area-wise things to work out, say like in your next example, you are having is one area, okay, maybe square, rectangle, we don't know what we have, what they are kept, but we make a general formula. Because if square is the real sides will become equal. Let us take first a general example as one rectangle, so that with different sides also we can have. So suppose they are kept like this. Keeping is not parallel to the plane of, you are not keeping the area. Listen carefully. The area is not kept The area is not kept like this, children. So area is kept what? Area is kept with its plane what? Facing the mirror. Okay, with area, the plane of that area has to face what? It has to face the mirror. Okay, so we are keeping that. We are keeping that. Okay. So suppose if I have kept here one rectangular one frame. Imagine one rectangular frame we are keeping. Say like this. Okay, you are kept like this, suppose. And see here, since you are keeping like this, now listen very carefully. If I take its breadth as B and height as suppose say, or I call it as L generally. So length, breadth, let us call for the rectangle. We know that when object is kept between the F and C, image has to form what? Image has to fall beyond the C. Okay, and to be magnified. Now listen carefully. See, if I have kept like this, where the image forms depends on what? Focal length of that mirror and the object distance. Now take every point of the breadth. Every point of the breadth is what? At the equal distance itself from the mirror, same distance. What is the every point of the length also or height also? It is also at the same distance. Then the whole frame will be having its image what? At the same distance itself. And once again what? It's the plane facing the what? The plane, okay, mirror aperture. Okay. So we are going to get what? We are going to get its image, imagine somewhere here, which is going to be magnified. Hope all of you got it. Its breadth as well as the length, okay, or the height. Both will be what? I can call it as B dash, I can call it as L dash. But distance is going to be what? Common distance. If I call this is at a distance U, I take this is at a distance what? B itself, children. A single distance, because we are not keeping the frame like this, we are keeping the frame like this. Hope everyone is clear. Now let us work out for the individual magnification. Let me find the magnification of B separately and L separately, because this is like one object I have kept, imagine, in front of the mirror. So I will find its magnification separately. This is like one object I have kept in front of the mirror. I will find its magnification separately. Okay. So what is the magnification of the breadth? You will write. You will write as what? You will write as the initial breadth and the final breadth the object. That becomes a B dash divided by what? B. Okay. So what is going to be B dash then? B dash becomes what? B dash becomes MB into B. Okay, this is your one equation. Now, what about the second case? In the second case, what you are having? So what about the length? So if you take magnification of length, I can write as L dash divided by what? L, its image by your object, okay, height. So L dash becomes what? So L dash becomes equal to ML into L. So let me call it as, now let me come to the, what is this magnification we are going to call? So we call this as aerial magnification. What we call? Aerial magnification. We are going to discuss, or it is also known as superficial magnification. Like in expansion you have come across. Okay, superficial, or we call it as aerial magnification is, here I am going to compare. What is aerial magnification is? So we can write the capital M. So aerial magnification what? I will compare the area of image with the what? Area of the object. Simple. Any magnification, what I told yesterday or in the previous class, children, it's only a comparison of image dimensions with your object dimensions. How many times it is increased or it is decreased. That gives you the what? Capacity of that particular optical instrument. maybe a lens, maybe a mirror or anything else. When you combine all the lenses, different lenses and all, you make microscopes and all, you say its resolving power is this much and all this. Okay. Even you come across angular magnification also, but I won't discuss here because that is required in the telescopes and all. For that, we should have the idea of lenses. Let us go for that angular magnification at that time. Right now, we cover only simple things. So, magnification, aerial magnification is what? This one. So, what is the area of the image you are having? You know rectangular formula. So, it becomes what? L dash into B dash. Divide by. What is this you are having? This is nothing but L into B. Okay. What L dash into B dash I can write as L dash is what? ML into what we are having? We are having as L. So similarly, this becomes MB into B divided by this is L. Now this got cancelled. We are getting is what? ML into M. Now, don't get scared. How to calculate again these things? So what formula we are having for the magnification? Linear magnification, because these both are what? They are linear magnification of, imagine one wire you have kept like this and linear magnification of one wire you have kept like this. Okay. So, but both magnification should be same itself, because when you take the breadth loss is what? At the same distance, and height loss is what? At the same distance. Obviously, image form loss is what? At the same distance. Since both their B dash and B or L dash and L, their V and U's are what? Same itself. Hence, I can take it as what? Since we are having ML equal to MB. Obviously, okay. However, you keep object, you keep one point object also. Only position counts, children. So, this position of the complete frame is same itself. So, obviously, they are going to form at the same position itself. V and U's are same. Or I'll give a simple funny thing to imagine. Imagine if these will form different positions, what will happen? Breadth will go separated, okay, from the frame. Height of that, it will be separate like this. So I'll be having the B here, I'll be having the L here. That won't happen. Okay, you are having this what? All the things together, frame as a frame itself. Okay. So we are having both of them as what? Same itself. So I can call it as what then? I can take it as M square. So what is the aerial magnification is given by? So we are having aerial magnification is given what, children? Square of the linear magnification. So important. So this you all learn, no problem. So this is not in your syllabus, but you should learn, okay? Because you have to solve the numericals. Now you can solve yourself, I think. Along with this, if other things are required, already other formulas you know, you try that numerical yourself, okay? Hope your learning is clear. Now we'll define one more magnification. Okay. So we defined already linear magnification, which you can even call it as what? You can call it as the lateral or the transverse magnification. Along with that, we learned the what? We learned the aerial magnification, which is going to be square of the linear magnification or lateral magnification. Now let us see one more magnification, children, and there will have the two concepts at once. Well, suppose if you are having a concave mirror and instead of keeping the object, a linear extended object like this or a frame like this, if you are keeping anything which is in the plane of this board itself, okay, one linear extended object or a frame you are keeping like this. So imagine, suppose if I have kept one object here. So one imagine a small needle I am keeping or a pin I am keeping. So I am keeping like this. So this is what my AB object. AB object. Okay. First I'll give the a rough idea. Then I'll go for a standard form. Okay. But there are conditions. So if I'm keeping AB like this, you know very well that or practically will observe that its image has to form what? Because both A and B are within the F and C kept. Okay, obviously this whole image has to form beyond the C. So I am expecting somewhere, imagine that you are going to get. And when you keep between F and C, it should be what? Magnified. Imagine we are getting A dash, B dash, okay, A dash, B dash, and it should be when I am drawing in the opposite direction because it should be what? Real image should be inverted. Okay, it should be inverted, not perpendicularly only. Even this way also you are going to see inverted. Laterally it should be inverted. Okay. So we are saying that it must be inverted. This is the situation. Now what is the common knowledge is? Common knowledge is I can take A position separately. Let me calculate its A dash position. I can call it as V1. Let me call this as what? V1 children. Taking this as what? U1 position. Similarly, I will take this as U2 and I'll calculate its image position as V2. So if at all you want to find what is the image length compared to the object length, okay, we can easily calculate as what? Subtracting V2 minus V1 gives me what? Image length. Object length is already given to you. If you want given, you can find the magnification. And this magnification is known as longitudinal magnification. What we call longitudinal magnification. Okay. So what is longitudinal magnification you are having? It is nothing but we are measuring, we are comparing the image, of course, minus should be there. So or you get when you work out, you get automatically minus. You'll understand why you get minus. So V2 minus V1 divided by what? We have it as U1 minus U. Okay, U1 minus yes, this separation and this separation. So image length and the object length. This is called as longitudinal magnification. So this you have to apply. Now listen carefully. This you have to apply. This systematic like this you have to work out. Usually whenever you are having if object length comparable to your other parameters given. What are the other parameters? Maybe object distance they may give. Whenever you give object distance, they give from the first point. Remember. Okay, or they mention, otherwise they mention. Otherwise you have to take what? Given distance you have to take what? This is itself you have to take it as object distance. Remember, if I say needle of suppose one question I have given. So needle of suppose some 10 centimeter is placed in front of a concave mirror of focal length something 30 centimeter I'll say. Now 10 centimeter and 30 centimeter what? Comparable, okay? So this length will not become negligible. So that time it becomes what? This becomes at a distance of suppose 40 centimeter. Focal length what I am saying? 30 centimeter, okay? And what is this length is 10 centimeter. And where I have kept I said at a distance of 40 centimeter. That 40 where you have take to the head of that. This first point of that object lying on the principal axis. Okay, not the next point. So what is the actual, this U1 position becomes 10 while calculating 40 plus 10. So by using U1 you have take 50. While using U2 and calculating V2 your take is what? 40. Hope everyone is clear. So systematically using our same formulas you have to calculate. But one more shortcut comes. But shortcut is not for this. Shortcut is suppose in place of giving 10 centimeter, if I had given only what? 1 centimeter. In place of giving 10 centimeter, if I have given only 1 centimeter, then this U1 minus U, I can call it as a DU length, a small length, and this Image also becomes ultimately according magnified also is what? But small only compared. Okay. So this I can take it as what? dv. So in this case, this becomes what? dv divided by du it becomes. dv by du it becomes. Hope this much is clear, children. But this will use only in what case? This is used only if suppose the length of object lying along the principal axis, if it is very small compared to your f whatever the other data are given to you. Clear? In that case, I can go for this. Otherwise, I have to use like 10 centimeter if I done, your job will increase. Okay, your work will increase. You have to calculate V1 once, V2 once while taking U2. It is only 40 centimeter. U1 becomes what? 40 plus length of the object. Okay, as per my diagram. Refer whatever notation you want. Hope everyone is clear. But for this, we'll make a quick formula which you can use easily. So suppose if you want to use this, let us go for our mirror formula. Now, through this I can give you the two formulas, hence I am working on. So I will rub this children, not necessary, or let it be. Hope everyone got it. I'll rub it. We'll go for the formula. So if I differentiate this with respect to time, whether the focal length is going to change, it won't change because focal length depends on what? Only cutting of the mirror, radius of curvature of the mirror. I said even it won't depend on where you are keeping the mirror, whether in the air or whether in the water or in some other liquid or the gases. Okay, so it doesn't make any difference. F remains same. With the time it will not change. Okay, unless you break and cut it. Okay, different matter. So you are going to have it as what? Same. So if I differentiate with respect to time, let us differentiate. This becomes what? Since it's a constant, that much idea you have learned already last year, many times we have used in the physics system. This becomes what? G. Okay. So df by dt is what? G. LHS is what? G. And what is your formula for the differentiation you are having? What is your formula is that? So u I can take it as to the power of minus 1. So d by dx of x to power of n. Formula is what? N times x to power of n minus 1. What you are having now? U to power of minus 1 is there. Okay. Hence it becomes what? Minus 1 times u to power of minus 1 minus 1. That becomes u to power of minus 2. Or I can take it as what? Minus 1 by u square. Okay. So let's take it as what? Minus 1 by u square into du by dt. U is position, children. U is position of the object. Don't forget. Okay. If you want for your comfort, use x, y, something like that. Whereas v is what? V is that also becomes same thing because this also changes. If object position changes with respect to time, image position has to change with respect to time. Okay. So v becomes what? Same thing. 1 by v square into we are having is dv by dt. Okay. So let me draw the once again same thing. Now I'll show you simply one point object. Imagine. So this is the principal focus is there. This is the center of curvature. If we know that, let us get the idea that when the object was at infinity, we had the image formed at what? Principal focus. When the object is somewhere beyond C, your image was what? Between, just observe that. Okay. Your image was between F and C. When I came to C, it became what? At C itself. When I enter the C, image goes beyond the C. Means they are moving in what? Opposite direction. So clear that they are having, if I take this as the object, if object is moving with some velocity, say VO. V is not no image, okay. V is what? V is the object speed, okay, object velocity. Whereas image is what? Image also is moving with, say, suppose vi, okay, with constant velocities. Now, what is then du by dt? What is u is? U is this position. It is, you can call it as x. If you want, you can call it as x. So, change of position with respect to time, what will you call? Speed of that particle. So, this became what? Speed of the object. So, this became what? Speed of the object. Okay, two things are going to work out here. 1 by u square, I can call it as what? Speed of the object. Minus 1 by v square, I can call it as speed of the image. Okay, so carry on. If I separate both the terms, it becomes what? 1 by u square into speed of the object. Speed of the object, this is minus 1 by v square. This is speed of the image. Speed of the image. Now, what is speed of the image? If I separate both of them, so I can write like this, one becomes positive, one becomes negative. So what is speed of the image? I write here, guys. I don't know. See or not. Speed of image is what? I can write as minus of v square by u square into what? Speed of the object. But what is our v by u is? V by u is actually minus m. But minus m square becomes what? Again m square itself. So what I can have? Speed of the image will be equal to what? Minus m square times speed of the object. So we use this formula in case of concave mirror. So in plane mirror or convex mirror also you can apply. In case of plane mirror, I had discussed about velocities. With what speed you move towards the mirror, with the same speed the image moves towards the mirror also. Whereas if mirror is at rest, we'll discuss some more situations soon after this. Okay. Hope everyone is clear. So what we are having? Speed of image can be found as what? Minus square of its linear magnification into speed of the object. Okay. Imagine, suppose if you are running towards a concave mirror with certain speed. In that case, you should know how to find the things. Okay. What is m is? M you take as per its initial position, or they are given magnification of that. Okay. The magnification be given. As per initial position, initial image position, you are going to calculate m, and accordingly calculate the m square into velocity of the object. Or if this is given, if this is question, we can calculate. Hope everyone enjoyed this. And now let me come back to this. But we are discussing actually what? Longitudinal magnification, how to find directly if length of object is negligible compared to the focal length of a given mirror. Okay, in that case, like 1 centimeter is there, focal length is 30, 40 centimeter is there, even 20 centimeter is there, it becomes negligible in that case. Now, instead of going to this step, what I do here is, I can write as 1 by u square into du by dt will be equal to what? Minus 1 by v square into dv by dt. See, dt got cancelled. So what I can write now? 1 by u square into du will be equal to what? Minus 1 by v square into d. Okay, what you want? You want is dv by d. So therefore, I can write dv by du. dv by du becomes what? Minus, also transfer this side, v square by u square. That is minus once again m square. See, we have d. This is that equal to what? Minus square of linear magnification. Previous aerial magnification also we had got as what? Square of magnification is the linear magnification. Now longitudinal magnification also we can find as what? Square of magnification. So easy to remember, children, easy to work out. Okay. But minus sign, what is indicating? Minus sign indicates what? What I have told? If suppose your needle is lying like this, you will get image what? Opposite, inverted. Okay. So minus sign indicates that it is inverted. Okay. So it is inverted. Away from that pointed thing. So what is the way of calculating? Hope everyone is clear. This is lateral magnification, longitudinal magnification, but this you can use only if with this condition, otherwise go systematically. And one more thing is what? We got your speed of the image in case of curved mirror. So is given as what? Minus m square times of the speed of the object. Let us have a clubbed concept numerical children. Then I'll come for your plane mirror. So one of the question you are having in the yesterday posted one that question paper. So question number 11 is the yesterday one more that 19 questions are posted in that. So very simple it is. A luminous object is placed. Hope all of you have noted the question. It will be easy for you. Otherwise, note the number 11th question. Okay. A luminous object is placed 20 centimeters from the surface of a convex mirror. What we are having? We are having is a convex mirror. Okay. We are having is a convex mirror. And where you are keeping the object? From this surface, you are keeping an object at the what? 20 centimeters. So let us imagine that we have kept the object at, it's a luminous object. Let me take like a point object itself. So this is our object. The object distance is given as what, children? It's given as 20 centimeter from the convex mirror. Let me take this mirror as M1. Okay, because one more mirror is there. A plane mirror is set so that virtual image is formed by both the mirrors are going to coincide. If the plane mirror distance is 12 centimeter, you have to find the focal length. Okay. See, both images has to coincide. Let me keep the again from here. 12 centimeter is the position of the plane mirror. So let me take 12 centimeter. This is what? This you are having as a plane mirror. Okay, this is a plane mirror. So what they have? Images of both of them are coinciding. This we need a lot of calculation, okay? But this is what? No calculation is required for a plane mirror. If I take it as M2, because we know that this distance is given as 12 centimeter. In case of plane mirror, object distance equal to what? Image distance. If suppose this is the principal focus of your the convex mirror also, this side also centimeter should be there, this side also what? The same 12 centimeter should be there, children. Hope all of you are following me. So where image should form due to the plane mirror, image has to form at the equal distance. This became what? Image formed due to the plane mirror, I2. But what they are saying, even image formed by the convex mirror also is what? Coinciding with the same. Means your I1 and I2s are what? At the same position. Okay, now it's very easy to make out. What is the image distance from directly geometry you can get it. So what is the image distance becomes with respect to the your convex mirror. So if I call this as V because we have to measure from the pole of the mirror, V becomes how much, children? This is 20 is there. If this is 12, left out is what? 8 centimeter. 8 plus 4. So we got as what? 4 centimeter positive in case of, because in the direction of incident. Okay, all these things are clear. Now, easily you can finish off yourself, I think, because you know object distance. What is the object distance for the convex mirror? We are working only for convex because question is to find the focal length of convex mirror. Okay. So U is how much we are having with respect to convex surface minus 20, always negative. Whereas V is how much you got? V we got as plus 4 children. So easy to find 1 by F equal to what? 1 by U plus 1 by, okay. So 1 by minus 20 plus V is 1 by 4. What you are expecting result should be positive because focal length of a convex mirror is positive. Keep in mind that works out. Even when you are finding, suppose image distance you have to find or focal length you have to find also. See how to make a guesswork in your objective questions is focal length should be what? Greater than 4 because this is to form what? Within the focal length itself. Okay. Like anywhere if you have kept the object, okay, somewhere imagine that beyond the scene case of concave mirror. You know where image has to form. Make a guesswork. Suppose 20 centimeters is the focal length of a concave mirror. If you have kept the object at 60 centimeter, image should come out between 20 to 40. Yeah, and so go for the options. If only one option is there, don't calculate. Okay, that you can take. But if the option is repeated, if the options are very close, then you have to calculate. Between 20 to 40, if you are having two values, go for calculation. Otherwise, please keep in mind your image formation helps a lot. So quickly you can answer if you are having distinct answers. Okay, it's as per expected. If only one answer is there, easily you can answer. Okay, now this becomes how much? 20 is the LCM. So minus 1 plus 5. Okay, so 20 by 4 means if you are going to get as what? Plus 5 to 7. So we are expecting positive, we got positive. Okay. So I did the clubbed concept also. You know to use even directly focal length, object distance magnification formula also. So you know magnification as minus V by how to work out also. Almost all the different type of questions are done. But practice them in your answers also I will post it. But let me go for the some plane mirror concepts left out because some of you are having still in that doubts. One more similar question is a triangle. Okay. So let's go for plane mirror. Observe carefully. Now observe carefully, children. I don't know whether that last case is required or not, but at least these we have to discuss. Imagine the first case. We are having this as an object. So very clearly I am going to explain. Certain things already you know. So let me make it more clear. So image object distance should be what? Equal to image distance. This becomes your image. Okay. Now suppose if the mirror itself is moving, if the mirror itself is moving with certain velocity Vm, okay, if mirror is moving with certain velocity Vm, okay, then what happens to the okay, image speed? Nothing is going to happen. let the mirror move like this, image remains what? At the same position. Okay, what we are having? Unless the object, if I take object speed as 0, it's at rest, then image also remains what? At rest. Means even though mirror I move like this, even though one imagine large mirror is there in front of you, if someone keeps on taking it away, okay, in this direction, but I find my image what? In front of me as it is. Okay, so the image distance also is what? Where I am as, so image speed also where I am as what? 0. This will be at rest in front of you itself. Now, if suppose I am having the object is moving here, okay. Now let the mirror be at rest as it is, but object I am going to move. If suppose we are having this as the object, and if the object starts moving parallel to the mirror in this direction, we are having what? Parallel to the mirror with speed u. Then what happens to image? At the same distance will be there, but now this will not be at rest. This also moves with your same speed. Okay. Hope you are following. If imagine this is my mirror user, if I start walking, then what happens? That will also walk with me what? With the same speed itself. Otherwise, how will you find when you go here? You will find your image beside you only. How will you find that? Okay, you cannot find. So the speed will be what? Same. So if object moves like this, so image also moves like this. That is very clear. But both will move with your same speed. Just I can show my hand. Okay. If my hand is moving parallel to this, you can see that its image also should be what? At the same position. Meaning is image speed and the object speeds are what? Object speeds are equal itself. Okay. Both the speeds are what? Equal in this case. Now, what if it's of moving parallel? If it is moving perpendicular, that idea already are having children. If mirror is at rest, and if the object is moving like this in this direction, then we know that image also moves with the what? Image also moves with the same speed itself with respect to what? Mirror. With respect to mirror. Okay, with respect to mirror, both will move with the same speed, whereas with respect to, if you take image with respect to object, it becomes double. That you all learned. Now next is important. What some of you may have that out. If mirror also is moving, okay. Imagine this is your object. Now observe carefully. And if mirror itself starts moving in this direction with certain speed, say Vm. The object I will take it as what? V of object I will take 0. Let it be at rest. Let it be at rest. Initially, so since your object distance should be equal to what? Image distance, where the image is supposed to be formed, image is supposed, imagine it was here. Initially, before this was built, I called as initial, okay, or I1, okay, or I initial. Okay, so initially image was here. So when the mirror starts moving, will you find any time that your image is at different distance? Imagine, okay, imagine, listen carefully, observe these things, enjoy these things at your home. If suppose someone is bringing a mirror is there, dressing table is there, in your home they are shifting somewhere, you are standing somewhere. Imagine you are standing beside your study table, okay. You are standing beside your study table. If they are bringing the mirror towards you, okay, they want to exchange maybe okay, your study table and that. So just they are bringing the mirror towards you. Inside the mirror, will you see is okay, in front of the beside the study table itself or somewhere else? No. Always you find beside the what? Study table itself. Again I am repeating. If someone is bringing a very heighted mirror is there, imagine. So dressing table mirror. If they are bringing towards you, then already you are standing. You are not moving. You are standing what? Beside the what? Beside the study table. Inside the mirror also you find yourself as what? Beside the study table itself. Means even though I move like this, but still I find myself beside the study table itself. Means The always object distance equal to what? Image distance itself is there with respect to mirror. Listen carefully. Imagine that it is moving with this much speed means after 1 second. Okay, say suppose if it has come here. This is your image position, sorry, mirror position. This is your new mirror position. Okay, so it has how much it has moved in 1 second? Obviously, VM distance only. It has moved to what? VM distance. And once if it is here, now how much is this distance? If initial distance between the mirror and the object, if I take it as something x, now how much will be there? X minus v distance. X minus vm distance. Then where image has to form with respect to this new position, image distance and object distance should be what? Same. So I am going to get my new position of the image as what? Here. This becomes I5. This becomes I5. Okay. Now you have to calculate what is the speed of the image. Now what is this distance is there, children? This also becomes what? This also should be x minus vm itself because object distance should be equal to image distance. Before how much was the distance? Before x was the distance. Okay. Before x was the distance. Then how much distance your image has moved through in 1 second? That itself becomes what? That itself becomes your obviously the image speed also. Okay, image speed also. How much you are going to get then? Before your total distance between this and this, how much was that? Between object and the image. But listen carefully now. So we had distance as what? So between the object and the image, the total distance was how much, children? Total distance was 2x. Total distance was 2x. Okay. Now, how much is the distance right now you are having? You are having it as this much. That is 2 times. Okay. So, how will you get this distance? Easily. So, new distance. If I call this as something, say x dash. It has moved to a distance x dash in 1 second. Okay, this by this itself becomes its speed. It becomes what? Image speed with respect to object because I am finding total distance. Okay, so 2x minus of 2 times we are having is x minus vm 2 times. Okay, so slowly check it afterwards. I am running out of time. So 2 times you are having x minus vm. Okay. So 2x got cancelled. Okay, because I am taking per second, we can write this as whole thing per second. Okay. So this gets cancelled. What we are left with? 2 times v. So 2 times. So what is the speed of the images there, children? Now make a conclusion. If mirror, I have given example of if mirror moves towards the object. Okay, if it goes away from the object, then situation is going to be different. Already idea I have how to work out the distances. Even while explaining this also, I have made with the relative velocity concept itself. Now also taking position first initially. Now also I am explaining the same thing. So if mirror moves with the speed of v towards the object, then with what speed the image is going to move? With double the speed of the mirror. Okay. But so in this case, that became, if I write only vi, that became what? With respect to ground, means it is the only speed of the image, the only rest. What if you want to calculate velocity of image with respect to object? So as usual, velocity of image minus velocity of object. What is velocity of image is 2 times velocity of mirror. And in this case, if at all object is moving in this direction, say with speed suppose v. Okay, and that becomes what? Minus of minus plus. Got it? Suppose if this is also moving with the what? V itself, then it becomes what? 2 times v plus v becomes 3. Means if mirror and object, If mirror and object are moving with your same speed towards each other, then what is the velocity of the image with respect to object becomes, children? 3 times of v. Hope the concept is clear. Now one more will get. So instead of moving either parallel to this or perpendicular to the mirror, if your object is moving, suppose in some other direction, so object is moving like this. This is your velocity of the object. Now let the mirror be at rest. Okay. This is at rest. This is at rest. What happens to your image here? Okay. So think vectorially. So I can take its component here. So let this be Vx, let this be Vy. And already you are very clear. So when the vector quantities are, enjoy with your vectors, children. Okay. So already you are very clear both individual workload. Okay. When in project I go to enjoy like that usually in the regular classes. So if it is moving like this also we know what happens. If it is moving like this also what happens? If I take this vector, is there any change in the velocity of image? No change. Okay. So like this should be what? Same. So I should have what? There is no change in the velocity of image in this direction. Let me call that OX, sorry, OY and OX. So this becomes IY. So there is no change. That remains what? Same distance. What about in this direction? If you take in this direction, you what? Moving with the same speed but in the what? Opposite direction. Moving with the same speed but moving with what? Opposite direction. Okay, so this becomes your velocity of image along the x direction. Okay, now their resultant becomes what? In this direction. Now one more thing. Whether the speeds are different, no same. Whether the speeds here are different, no same. Okay, so since speeds are not different, ultimately their resultant here as well as here. How will you calculate? Since if I call it as something v dash, this also has v dash, this also becomes what? V dash itself, this also becomes what? V dash itself. By 90. So here also how will you calculate? Square root of 2 times of v dash, because at right angle. Square root of 2 times of v dash. Means by magnitude they are same. Say suppose if it is moving with 2 meters per second, this also moves with what? 2 meters per second itself. But here your components or when you write in the resolved form they are not same. Why? If I express this as what? Suppose if I express this as VO if I write as Vx I cap plus Vy j cap, shall write as suppose if I am having let me write as it is. Okay. So if I write like this, what will you write? Vy, V of I write as minus because this is opposite to this but equal. Minus Vox I cap minus this and this are equal. There is no change in direction also. So you write as Voy j cap. So this got what? Change. But see the mirrors carefully how they are kept. So depending on the mirrors, the things will change. Because same mirror if I kept like this, if the object is moving in this way, if the object is moving in this way, now this component not change, this component changes. Okay, so observe the mirror carefully how they are kept, and do remember that feature is perpendicular to the mirror, that becomes only negative, equal only with the negative. Suppose if again object moves with the speed of object speed, if I give it as say 2x 2i cap plus 3j cap in this situation. Okay, then what will be your image speed, children? Minus 2i cap because only horizontal component change in this case. Okay, plus 3j cap remains as it is. Hope everyone is clear. Okay, this is one concept. Now let me come for the one more, children. Hope everyone enjoyed this and it's clear. Whenever you are having two dimensions, split and work, in this please work it out if mirror is going away from the object. Okay. One I have shown clearly, one more you try. So let us have one more quickly. Two more are there actually. Imagine that you are having two plane mirrors placed, making some aligned, making some acute angle. Acute angle like this. Okay. And if a ray is incident, let me call it as M1 and M2. If you make anywhere ray incident, that is going to reflect like this, and again once again it reflects like this. Okay. Initially where it is entering like this. Finally where it is here. Means how much it has turned through? It has turned through this much angle. Okay, so through this much angle it is turned. This became total deviation. Okay. If angle between these two is theta, they'll ask you what is the total deviation. Okay. I'll just give the hint how to work out. One deviation takes place here, children. Let me call it as delta 1. Draw here one thing. One normal at this point of incidence. Let me take these both as alpha and alpha. So what is the delta 1 is going to be? I can write as 180 minus 2 alpha. 180 minus 2 alpha. Similarly, if I take here beta and beta, because angle of incidence equal to angle of reflection. So after this, the ray would again continue like this. Again deviated by what? This much. Okay. So what is delta 2 then? Only two deviations are there. That itself must be a total deviation you know. So delta 2 becomes what once again? 180 minus 2 beta. 180 minus 2 beta. Now observe here. This is a normally drawn for this plane. This is a normally drawn. So if I remove the alpha, this angle becomes what? 90 minus alpha. 90 minus alpha. Similarly, this is a normally having. If I remove this, this becomes what? 90 minus beta. The total angle in this triangle should be how much? 180 degrees. Therefore, theta should be how much? Alpha plus beta. This is important. Work out once again, taking this triangle. So, theta should be how much? Alpha plus beta. So what is your total deviation then, children? Delta becomes how much? Delta will be equal to delta 1 plus delta 2. That became 360 minus of 2 times alpha plus beta. But alpha plus beta is what? Theta. 2 times theta. Very important shortcut to work. So what we can do? When your two mirrors are aligned, but acute angle should be there. Otherwise, your shortcut is not one mode. Okay, geometrical lines. So, but this all is not required when your acute is there. Let it be incident wherever. Doesn't make any difference. Okay. So you are going to have it as what directly 360 minus 2 theta. And sometimes they'll ask you number of images found also, giving deviation or something. Easy to find. Already once theta is known, you know how to work it out. Okay. Depending on even or odd. If odd is symmetrical or asymmetrical, whenever they won't mention, you have to take granted as symmetrical. Okay, so this was one concept what I wanted to explain children. So remember the formula for acute arrangement. Okay, acute angle arrangement. So last one I will take. Your chemistry sir will be waiting already. Suppose if you are having a plane mirror, because one of the students had asked. Plane mirror is the and. Let us keep. I am taking directly example. This example is with the parallelly arranged plane mirrors. Okay. Let's write that one bit far. Let me take this as one plane mirror. I will draw the another one bit far. These two plane mirrors are placed facing each other. Okay, facing each other. These are the reflecting surfaces. If I keep an object between this, say suppose I will keep here. This is our object. Say this is, I will give directly the example. This side 2 centimeters, this side 3 centimeters. Okay. Let me call it as M1 and M. They number sometimes go accordingly, X, Y, something, whatever is it. So first image forms due to this side is what? At 2 centimeter only, I will call it as I1. And this side I call it as I2. This will be at 3 centimeter. Just 2 minutes. 3 centimeter and this will be what? 2 centimeter. Now, this became first image formed by the other. Now this acts as what? Virtual object for the second. Listen carefully. This acts as virtual object for the second mirror, children. And if it acts as virtual object for the second mirror, what is the total distance you are having? 5 plus 2 means total distance became 7. In case of plane mirror, object distance should be equal to what? Image distance. Means from here at 7 centimeter it is going to form. This I call it as I2. Okay, it forms what? At 7 centimeter. Okay, now this acts as what? Virtual object for the what? Again this one. What is the total distance? 7 plus 5. Totally 12 is there. Then behind this, from here, I am getting somewhere at what? 12 centimeter our I4. If I go on forming like this, never ending. We get actually what? Infinite number of images. Infinite number of images. So actually, one of the students asked, keeping L letter. Do the carry on the same thing? I don't know where it is. Do the same thing. The first one for both will become what? Inverted lines. Means laterally inverted. Okay. They will become what? Laterally inverted. So count like this, but now this acts as what? Virtual object for this. So it's the second image when it is forming, it will become correct again. But question was how many get laterally inverted. So carry on like this and please check. I think you are getting the 4 images. Of course, I agree, infinite will be there. But question is within 7 formation, 7 images something is there. Check. Accordingly it comes as 4. Hope you got the idea. Now this also becomes what? Again correct next round. Okay. So here I got what? Within 4 image formation already I got what? Only 2 lateral inverted. So go for the 7 image. Now for the distance to find there is a shortcut children. Okay. If I take M1 and M2, what is your first image formed by both of them? They were at what distance? 2 centimeter and 3 centimeter. Okay, means same distance. 2 centimeter, 3 centimeter. So second image formed. Second image formed. For the first mirror is at what distance? We are having it as, sorry. Next image formed is what? This side is. Okay. We have taken this side. So this side next image formed is what? At what distance you are having? 7 centimeter. Okay. So 7 is what? 7 is nothing but 2 plus 5. So what you can do is just go on bring on the either side plus 5. The separation between, if I call it as a D children, B, make it as just plus B. Plus B. Okay, plus B is how much? 5 centimeter. So second image, this side becomes what? 2 plus 5 we got as how much? We got as 7. Similarly, you have to make this side also. Okay. So this side, I took directly this. This side says I should take one more. This side says a virtual object. Okay. So actually I4 is not this one. This becomes the I6. Okay. This side says virtual object. So 3 plus 5, where it should form 8. Means I have to get one more here. So this should be 8. Okay. Hope you got it. 8. This is I4 I am getting is 8. Okay. So second image for here is what? 3 plus 5. Like this here also I should make plus 5. Same. Plus B. So 3 plus 5 became what? 8. Hope all of you are clear. Then is it carry on. What will be the third image this side? Again 8 plus 5. 8 plus 5 is 13. Okay, this is a shortcut what you have to use. Again this side, 7 plus 5 is what? 12, that's what I have got, okay. Plus 5, so third image. So they'll ask you, for example, what is the distance of third image from the form, okay, behind your M1? Third image is what? 12. If ask fourth image becomes what, children? 13 plus 5. That becomes 18. Hope you got how to answer. If asked what is the distance of second image formed by the M2, so second what you have got? 7 cm. So only what you have to do, first images you know how to write equal distances, then go on adding in crossway this total separation between them. That becomes your answer. Okay, other student question was this, hope the student is able to solve. Thank you children. I think tomorrow we will be having the exam. Do well. I'll just post the okay all the answers for the given question paper also. If any doubts are there, you can just put it on the WhatsApp. Thank you children. Good.